Well, thanks for coming. This session is about container runtime security. Question first, how many people here know Falco? Can you raise hands? Oh, so like half of the audience. That's great. I hope you learned something extra from Falco today. My name is Jorge. I run tech marketing at Sysdig, and I'm very involved in the Falco project, which started at Sysdig, but now it's part of the CNCF umbrella. So Falco, for the ones who haven't heard about it before, it's a behavioral activity monitoring tool. That basically means that we can detect suspicious activity defined by a set of policy rules. And those rules, they are created using the Sysdig flexible query language or filtering language. As Sysdig, Falco can talk to your container and orchestration tool, Docker, Rocket, Cryo, Kubernetes, all of those. And when we detect any indicator of compromise and a security event, we can send notifications to multiple places and use those notifications to do more interesting things. Falco, it's fully open source. Now it's an independent project. We have some external contributors being part of the project now. And that's one of the reasons why we are here today, to bring more and more people. As I was saying before, now it's part of the CNCF umbrella. So that's why we have the opportunity to speak here today. And it's the first project for runtime security, so it's pretty unique. Right now, it's on the sandbox level, but as more people get involved in the project, we hope that we can grow that soon. This is slightly outdated, but I still wanted to keep it here. We participate on Google Summer of Code, and actually this summer, there are a couple of students working on performance of the eBPF filtering part, which is pretty cool. So, sorry, you're late for next year, or for this year, but hopefully, if you're interested, you can get involved next year. I like to compare Falco with home security. So let me give you an example of how we could establish some similarities between implementing security at your home and implementing security on containers. So at home, when we want to prevent intrusion, so we do door locks, window sensors, bars on the windows, even exterior cameras. So when you do that on what you want to see what's happening inside, you put basically motion sensors and interior cameras. And probably, maybe not in this room, but on the venue you have seen, apart from the main doors, we have cameras inside. So it's like a very popular approach for home security. What if we wanted to do the same thing with computers? Well, to prevent the entry point, we use credentials and password, two-factor authentication. We can do even container image scanning to find known vulnerabilities. We can deploy Kubernetes admission controllers, establish Kubernetes network policies. But what about those internal motion sensors? What would be the analogy on the container world? Well, we need to detect once the intrusion has happened, and what do we do from there? So we can look at Kubernetes audit logs. We'll talk a little bit more about it later. But we can also look at the container activity, what's happening inside the container. And we can do that using a system called instrumentation. There is one thing that differentiates containers from VMs, which is they share the kernel with the host. So if we look at the kernel, we'll be able to see a lot of what's happening inside. We can use that information of what's happening to detect anomalies, to detect what it shouldn't be happening. Containers are isolated processes. Usually the purpose of a container is just one thing, so it's very easy to detect that specific container is not doing what it's not supposed to do. Container images are immutable, but once they are running, the image can be changed. Not the image, but the container can be changed. So we need to look at that. We need to look at container. And what is that? What are the use cases? How we can effectively use this kind of approach? Well, we can use for zero-day vulnerabilities that they don't have a CVE, so image scanning tools, they cannot understand those attacks. We can also look for wrong configuration, insecure configuration, like default passwords that they are being exploited to get inside a container and then do unexpected things inside. But also weak or leak credentials, any kind of internal malicious activity, who knows? Anything else that it's not a known vulnerability potentially can be identified, captured using runtime security. So we want to block these kind of things. The approach of Falco actually is not new. We can establish some analogies if we look back in time and we look at the history. So back in the day when we wanted to do connection or network traffic filtering, we could use tools like TCP dump. From there, more complex tools that allow us to analyze network activity were developed, like Ethereal, Wireshark. So Sysdig open source and Falco basically take the ideas of these tools and they translate them into the entire system. So if for doing network security, you were using Snore to detect the attacks and to block them, and Wireshark to analyze that network activity, on looking at the entire system activity and specifically to containers, we can use Falco to detect and block those potential attacks, but also Sysdig to do some analysis. Let me tell you a little bit more about how this works. The idea is that we are going to be able to deploy Falco as a container in our Kubernetes infrastructure, for example, and it's going to hook into the kernel, capture all the system calls, move them into the user space, and do all sorts of things. So we have an eBPF proof. That's the technology that allows to capture the system calls. Through a set of libraries, those system calls, they are put into some kind of a state machine, so we can correlate ones with each other, and then they go into a filtering engine where all that activity is matched against the security policy that we have created. If there is something that matches, we can generate an alert and send it to multiple places. Additionally, and we will see that now, Sysdig can ingest events coming from different sources, including Kubernetes audit. But you might be wondering how we can use like kernel system calls for container security. You're talking about something extremely low level with something very high level. Actually, if we think a little bit under the hood, we can quickly see that if we see clone or execve system calls, it's because there is a new process that was executed. If we see open, close, read, write system calls, that means that there is some kind of I/O activity, either on a file or on the network. If we see socket connect accept, that means that those sockets or those file descriptors, they belong to network activity. So building from these very low-level concepts, we can come up with high activity or high level ideas. It's like kind of magic. To define these rules, we use human-friendly language, which is YAML-based, something like this. So you don't need to have that low-level knowledge. You don't need to think about system calls all the time. There is an abstraction on top of that. Let me get into the details of this language. We have macros that allows us to create expressions that can be referred by a name. We can create lists of binaries or ports, whatever. And then we create rules. A rule basically has a name, a description, a condition, where is all the magic happening, an output message that goes into the log, on the alert, and then a priority. Those conditions, they are built using Sysdig filtering expressions, and we can, what's really interesting here is that we can pull in Kubernetes metadata. So we could say, give me all the system calls of the deployments inside this namespace. And from there, we can filter for interesting things. So for, I don't know, I want to see network activity, or I want to see running processes. All those rules are combined into that filtering engine. And at least one rule needs to contain a specific system call or a macro that has that system call underneath. Usually, we use a macro. There are many things we can filter on. So file descriptor, processes, events, user groups, container metadata, Kubernetes, so a lot of things. We will see this better with a few examples. So for example, if we want to detect if a shell was running a container, we can do that first one. Container.id is not equal to host. And then there is a process which name is bash. Quick example. If we want to see if someone is overwriting system binaries, that shouldn't be the case in our container, because we were saying that images, they shouldn't be changed. Well, we can do fd directory in that list, and then the operation is right. So these are just a few examples of basic things you can do with Falco. So what do we do there? Once we trigger one of these conditions, we generate an event or an alert. These, they can be sent to different places like syslog, or file, standard output, or they can be piped into a command and start doing more interesting things with them. This is what a more real-life Falco rule would like. So we have the rule name, the description, detect the process that it's not a node, it started in a node container. And the condition is going to be something like this. So event type, execve. So we are looking for a new command or process started. And where? Well, we do container.image, starts with node. That's very simple. We use container metadata, not Kubernetes metadata in this case. And then we do process name, it's not node. So if at any point in time there is any process, any command, if anything executed in that container that it's not the node engine, this will trigger an alert. But in addition to all this information coming from system calls, we can leverage other sources. And probably one of the most interesting ones is Kubernetes audit log events. Since Kubernetes 1.11, there is a functionality that provides a set of records of anything changed on the cluster, anything changed through the Kubernetes API server. So anything you do with kubectl, for example, goes through the API server and can be potentially recorded in an audit log. What you do with that audit log, you can send it into simple log files, but you can also use webhooks to send those events somewhere else, a place like Falco, for example. They look something like these, like a JSON. So for example, here we can see how a user called minikube_user tried to delete a namespace which was called foo, and this operation was completed successfully because it's response code 200. With these objects, once we get an inside Falco, we can access to all the different fields and values. So time, the user, the action, the resource, all this is available so we can create Falco rules. And this is a very cool example of the functionality that you can implement. Imagine you want to audit if any of the users of your cluster, they are storing credentials in a config map instead of secrets, something that they shouldn't be doing. So basically what we do here is, let me see if I can, there we go. So we can detect or we can create a macro that contains numbers of strings that can potentially be credentials like AWS access key or just passwords. Then we create another macro that's called config map that has that filtering condition of the target resource, it's a config map. And finally, the third, there is another modify action where we aggregate creating a config map, updating a config map, or patching a config map, which are the three different ways that we can make changes into a config map. So with all these three macros, we can create the final rule. So if you look specifically at the condition, basically what we are doing is just combining the three macros. If there is a config map, and there is a modification action against that config map, and the payload of that action contains any of the strings that I can potentially identify as credentials being pushed into that config map, I'll just trigger a security event, and actually I will be logging the entire config map. That's a feature, so we force the developers to rotate out credentials, so that's pretty cool. So this is the basic functionality of Falco, but we can actually do a bunch more of things. First, let's see how we would be installing Falco. Falco can be installed using a system package, easy, using a one-liner script that you shouldn't do. It's also available as a container and a bunch of other installation methods. But probably if you're using Kubernetes, you want to use things like our Helm chart or the operator, or you can also use it, install it manually using, using a daemon set. Configuration will go into config map, and the Falco pod will be connected into the Kubernetes API, so we can pull in all these metadata that we need for building the rules. This also creates an airbag permissions under the hood, so Falco has read-only access to the Kubernetes API. So once we have installed Falco and we have installed a bunch of different policy rules, how we can do something else other than alerting? Well, for doing that, we created something called Response Engine. The idea is that with all these events that Falco is going to trigger, we are going to define a set of reactions that can just log, audit, but also block potential threats. So the moving pieces in this security toolkit are going to be Falco as the engine or the piece to detect a normal activity. We are going to be forwarding events into a message broker like NATS. And then the way we are going to react to these events, it's using functions as a service that they run, in this case, in kubeless. So the idea is that we are going to create different topics with the different policies that they can be triggered and with all the different priorities. And then different functions as a service, they can subscribe to those topics. And you can build your own responses, but we are providing a bunch of popular or typical reactions that they are quite cool. So for example, we can kill the pod. If there is any suspicious activity on a pod, we kill it. Kubernetes will spawn a clean new pod. But if we want to, for example, we fear that might have been a container breakout on a container, on a pod, we can say, well, don't schedule any other pods in that node until I do further analysis. I can also isolate the pod, so no new connections, they go against that specific container using Kubernetes network policy. Of course, we can send notifications and do things like Slack. And we can also take Sysdig capture. Sysdig capture is basically dumping all the system activity into a file that we can use for forensics analysis and postmortem once a container is long gone. So if we wanted to see all these moving pieces working together, this would look like this. So Falco, detecting all the system activity, all the activity from the containers, the Kubernetes nodes, also pulling in the metadata, but also pulling in events, and then forwarding any alerts that they get triggered into NATS. Then we have the different functions as a service here, subscribing to the different topics, and then kubeless can execute code for forwarding events somewhere else, like in this case a Splunk, or to connect again to the Kubernetes API to kill the offending pod, to give you an example. The very same architecture can also be deployed on AWS using hosted AWS services like SNS and Lambda. But if you're using Google, we can also do the same thing, using Google PubSub and Google Cloud Functions, and even forwarding events to Google Cloud Security Command Center. Most of the people, they want to record all the events that they were triggered. And security people, probably they want to see this in their SIEM. We can do that, or you can just log them into a typical solution like Elasticsearch, Fluentd, and Kibana. So you can create beautiful dashboards like this. So you can get a little bit of idea of what's happening on your clusters when you have a lot of working containers. And now I'm going to show you a little bit of a demo. I don't know how much time is left. Wait a minute, all right. So I have here deployed this is probably not good. So let me change the profile into something that you can see. Probably one less. Transparency. There we go. So just very simple. Let's see if this is working. That's a good start for a demo. There we go. So that's very simple, just one node cluster running on GKE. I have previously installed Falco like this. I'm not going to do it again. Helm install Falco, and then I'm just going to enable forwarding events into nets. And additionally, I'm going to install the eBPF pref. So that will get installed. Actually, we can have a look at it. It's running. And then the other thing I've done here is to deploy this Kubernetes response engine. That basically is going to install kubeless, which is my functions as a service framework, and it's going to install NAT, which is a message broker. If I look at my running services, I see I have Falco here, and then, well, some Kubernetes things, and then I have kubeless running here, and then NATs, which was installed using the operator. Using, let me see, where is this? On this playbooks folder, I have this script that I can use to deploy these functions as a service. So I can use this deploy playbook, and then I give it an action. So what I'm going to, when I see the following policy violation on Falco, I'm going to react with the following playbook. So the playbook is delete. I have already deployed this, and actually if I do function list, I can see here, well, this is maybe too big, how this Falco delete function, it's installed, and actually I can also see the trigger list. Trigger. Why not trigger? There you go. Thank you. There we go. So that's the trigger that connects the event on NATs with the functions as a service. And what I'm going to do now is to show you, there is a default policy, which is that terminal shell into a container. So what I can do now is get pods. Let me see. I have deployed a dummy Nginx pod here. So what I'm going to do is to run just a bash into the container. And I didn't even have time to do nothing. The policy was triggered, sent an event to NATs, and immediately kubeless executed a playbook to delete the pod. Let me see. Well, that's a quick demo. I can show you more things. But, well, we would, if you like this, and every KubeCon I come and we talk more about Falco, more and more people, they come and say, hey, yeah, I deploy Falco on every Kubernetes cluster I deploy. Someone was telling me this morning, and I think that's awesome. But now we want to go to the next level and get even more people involved contributing things. And probably one of the easiest way to get this started contributing into Falco, it's writing policies, writing rules. We created default policies or rules for the top 10, 15 most popular container images on Docker Hub, and that's available on that URL over there. So if you are using other container images, if you can send pull requests, again, that repo with your default rule sets, that will be awesome. I hear of people doing advanced policies for detecting crypto mining in their containers and things like that. So we would be awesome if you could share those and contribute. Additionally, ingesting events from multiple sources, now it's available as a small framework within Falco. One of the first implementations, it's for ingesting Kubernetes audit events, but we can ingest all things. So if you're using a specific database or a different orchestration tool, or I don't know, something that generates events, if you can also think about writing that translator to bring those events into the Falco engine, which at the end of the day just filters for activity. Additionally, another easy way to get started in the project is writing output destinations. So I showed you before how Falco can send events into standard output, syslog, just plain logs, but also how it can be sent into NATs or into Amazon SNS or Google PubSub. I don't know, if you are, for example, using Kafka, maybe it's a cool idea to write an event forward into Kafka. Also into other logging services or web services. A few links that you might find interesting. Falco website, the Slack channel. We write often on the Sysdig blog about Falco. GitHub, documentation, Docker Hub. Just if you want to take a picture, or their slides are going to be available. And that's everything I had on my list. And I think I have 5 more minutes. So I think we are on time. If you have any questions, raise your hand. John will bring the microphone for you, so we get your question on the video. We have one question here.
Hi, thank you. So basically my question, if you get the event of violation, it happens asynchronously, so it might take time until you kill the pod or stuff like this, and it did a lot of damage, but you did it too late. Is it possible, right?
Yeah, that's possible. Processing the event can take time, but forwarding the event can take time. Falco, it's really, really fast. So the detection of the event, it's going to be super fast. We cannot give you any guarantees how fast NATS is going to be or how fast kubeless is going to be to react.
Mm-hmm. But by design, it doesn't promise.
We don't make any promise there.
Mm-hmm. Thank you.
Hello. Do you still require Sysdig kernel modular? This can work just with BPF filters.
So Falco uses the Sysdig libraries for system call collection, decoding on all the state machine. The end user binary, they are completely different. So they share a lot of the technology, but you don't need to install Sysdig binary to get Falco running.
Okay, so I could have Falco and configure just BPF as the backend.
Yes.
So I don't need the kernel module.
You don't need a kernel module.
Okay. Right.
You require a newer kernel to have all the eBPF things, but yeah, you don't need a kernel module anymore.
Okay, great, thanks.
Hi, sorry if you answered this earlier, but can I use Falco to distribute and execute arbitrary eBPF programs?
No, that's not the function. Falco, it's quite a big eBPF implementation, and it uses eBPF to do all the filtering, but you cannot write eBPF bytecode to get executed on the kernel. No, that's not the function.
Okay, cool.
Hey, is there any plan to expose Prometheus metrics to be more kind of alert-based rather than having this additional tooling around the outside that you would require in order to be able to know theoretically that something's gone wrong? So obviously you can push it to the logs and you can look there, but that's very kind of reactive. Whereas kind of exposing Prometheus metrics on a per rule basis would mean that we could be more proactive without necessarily having to immediately kind of kill the pod like you described there.
So that's a complex question. A few things there. So we are, it's on the roadmap to implement metrics. So Falco will be exposing Prometheus metrics on the rules. So you will be able to bring that into Prometheus with Grafana and see trends over there. Once we have the metrics, well, not even metrics needed. One of the things we want to explore is if we can connect all these events into some kind of like machine learning something where rules can be auto-generated based on previous behavior. I don't know. It would be great to have more thoughts on the different things that can be done towards that direction. I know there's a bunch of people hanging out on the Slack channel that they are working on some POCs. So maybe it's better to ask there. I'm not directly working into any machine learning as of right now. Does that answer your question more or less? Okay, cool.
Hi. Is there any kind of latency penalties when you are getting the system calls? Because it's like you are a sniffer and should not be free.
That's correct. So we need to identify, or we need to look at performance impact in two different levels. So there is one level which is capturing the system calls. Capturing the system calls, it's highly efficient and can be, and it's non-blocking and completely asynchronous. It goes into a shared buffer, moving into the user space, and actually the impact that it has is a few nanoseconds. Now, the challenge goes into analyzing all those system calls. And then that depends on a bunch of factors. So if you create very complex rules, imagine you have a rule that looks at the payload of a system call every single time, because you're looking, I don't know, for a string into a network socket connection. That's going to have a huge performance impact. So the way you create rules is you try to capture the system call you are interested as early as possible in the filtering engine process. So I don't know if you saw it before. If we are looking for new processes, the first thing in the entire condition evaluation is I'm looking for execb system calls. So rules must be written thinking on performance, because you can write terrible rules that will have a huge performance impact. But typically, when rules are properly written, it has a very low performance impact. It's typically on CPU usage. The new version, the latest version we released on Falco, also has some mechanisms to alert if you're hitting performance limits to say, well, there are so many system calls that I need to drop some. That's already an indicator of a compromise. So that's not a problem with Falco specifically. This is the same thing with Snort. Like, what do you do if you have so much network traffic that you cannot analyze it? It's a capacity planning. If there is already, so when you plan your Falco deployment, you should already think what's the analysis capacity that you need and prepare accordingly for that. And then if there is way more than expected, that's already an anomalous event that you should look at.
Thank you.
Well, I think this is it. Michael Yusey, who is standing over there, is doing a deep dive on all these concepts. When is your session? Tomorrow, tomorrow sometime, right? Falco deep dive. Yeah, in the morning. Okay, well, thanks very much. And if you want to see like more use cases or demos, some of the Falco contributors are hanging around here, so talk to us. We'll be happy to share more. Thank you.